Hello, my name's Michael Kinsey and I'm a PhD student in the Fire Safety Engineering group at the University of Greenwich. In this presentation I'm going to give a brief overview of the work I've been doing for my PhD entitled Evacuation Modelling of Vertical Transport and Associated Pedestrian Behaviour. My supervisors are Professor Ed Gallia and Dr. Peter Lawrence. I'm funded by the Engineering and Physical Sciences Research Council. I'm in the UK, and I'd also like to acknowledge the contributions of Dr. Andis Granderson, Dr. Jaldra Wang, Dr. Lynn Hulse and Rachel Day. In the presentation I'm going to give a brief overview of circulation and evacuation modelling, talk a bit about the Exodus software we develop at the university, moving on to the what is a vertical transportation device and why might we want to model them, and hopefully this will define a context for the aims of the research. I'm going to talk a little bit about some of the past work that has been done by other people, and then I'm going to dive straight into the work that I've done. I'll then summarise the work. So what is circulation or evacuation modelling? Well, essentially it's a simulation of human behaviour within structures during either circulation scenarios or evacuation scenarios. And this just doesn't have to be buildings, this can be ships, aircraft, or any structure which houses people. So why do we want to simulate people evacuating these structures? Well, it's often used to help improve existing design or instruct new design to make them safer for people during evacuations. They're often safer, faster, cheaper than actual evacuation trials as well. More information can typically be extrapolated from a model than can be from an actual trial evacuation. It's often not feasible to run trials in buildings or structures which house many people due to the logistics and cost. At the university we developed a piece of software called Building Exodus, and this is an example of an evacuation simulation software where we can simulate people evacuating a structure. People are represented as a series of attributes, and a geometry is represented by a series of nodes and arcs. You can see a simplistic picture of a geometry in the bottom right corner here, where the nodes are represented as green squares and they're connected via arcs. People traverse the geometry between nodes via the arcs. You can also see a broad overview of the conceptual submodels within Building Exodus. So what is a vertical transportation device? Well, essentially it's any device which can transport people within a building vertically. So for the sake of my research, this includes escalators and lifts. So why would anyone want to model these? Well, there are a number of buildings which heavily rely on these devices during normal circulation scenarios. These include high-rise buildings, skyscrapers for lifts, and underground or subway stations for escalators. At present, most other evacuation models represent these devices as either the same way they represent stairs or as a very simplified flow rate model. You might be asking yourself, well, you're not allowed to use lifts during an evacuation. Well, that's absolutely true in most buildings throughout the world. However, with the increasing number of high-rise buildings and events such as 9/11 and the bombings in London of 7/7 has raised questions as to whether we perhaps should be using lifts or escalators to evacuate buildings. There are essentially three challenges with automated vertical transport egress. They are mechanical and electrical. How can we make the inner workings of escalators and lifts safe during an evacuation? There are operational issues. If these devices are safe, how can we best use them? And there are also human factors issues. How are people going to behave given that they've got the choice to use these devices? Evacuation simulation can be used to explore both operational and human factors issues. So my research can be split up into three parts. There is the data collection phase, where we've tried to gain an understanding of how people would behave on and around lifts and escalators during an evacuation, and we've tried to quantify this behaviour. We've quantified this behaviour, and based on the data we've collected, we've developed a series of models within the Building Exodus software to represent the behaviour. We've also run a series of simulations, modelling simulations, to see how different human behaviour will influence different operational strategies. If we look at the past work which has been done by other people, we can see that actually quite a bit of work has been done on how people behave on stairs by Fruin, Templar and Pauls and a variety of other people. However, not a great deal of work has been done looking at how people behave on escalators and lifts. Some work has been done looking at how lifts should be used, operational strategies, but not a great deal of work has been done looking at how people would behave. So there's clearly a niche for the work we're doing here. Okay, so if we start looking at the work I've been doing with regards to data collection and quantification of human factors on these devices. With regards to escalators, we've collected data of pedestrians on and around escalators in 3 different cities throughout the world, and we've collected data of some 20,000 escalator users in both China, Spain and the UK. And the sort of data we've been collecting relates to how fast people walk on escalators, the proportion of people that use the right, the left, the centre or varied sides of the escalator, the proportion of people that use the stairs and the escalator, the proportion of people that walk or ride, the number of people which can board the escalator each minute, and we've looked at exploring these characteristics in both rush hour and non-rush hour periods at different times of the day. We've looked at seeing if gender influences this behaviour and whether there's any differences between how people behave in different countries. Okay, so to give you an idea of some of the video footage we collected, which we extrapolated data from, here we can see a video of the People's Square Underground station in Shanghai, and here we have a platform with trains arriving at either side. And if we play this video, we can see that people get off trains on either sides and it gets very crowded very quickly. And really this highlights the importance of understanding how people use escalators and stairs during circulation scenarios, so that we can apply it and see how this might influence operational strategies during evacuation scenarios. Okay, with regards to lifts, if you remember, we said that actually most people are told that they're not supposed to use lifts during an evacuation. So what we decided to do to collect data on how people might behave during an evacuation with regards to lifts is conduct an online survey. And in the survey we presented a series of hypothetical situations where participants would say how they would behave in a given situation. And we were using the survey to help identify and quantify the influence of travel distance, past usage, queue length and a variety of other factors on lift usage. Some of the example data we've collected relates to the number of floors people would consider walking on the stairs before choosing to use a lift, the crowd density in a lift waiting area which would cause them to redirect to use the stairs, and how long people would be prepared to wait for a lift before they redirected to use the stairs, all during an evacuation simulation.